guys, in the today's lecture I will be discussing about the another two problems of the mechanics part. Okay, so let's start. It is the continuation of the lecture 2. Previously I am already discussed about the lecture 1 and lecture 2. If you don't follow the lectures, please saw it, then you can easily understand this lecture. In the previous lecture, from the previous lecture, you can understand the basics of the mechanics and the steps of the mechanics also. Okay, so let's start. So this is the first question. In the first question, it is given that a boom is connected by a string through this box. By this string is the boom connected. It is called a boom or it is called a stick, and from this point of the boom, a 1500 Newton hanging from that point, means 1500 Newton force is given in the direction of the ground. Okay, and the boom length of the boom is 30 meter and the string length is 15 meter. Okay, so find the forces in the boom. Means at first you need to draw the FBD of the boom and then find the all forces which is acts in the boom. Okay, so let's start. At first I told you that I need to draw the FBD. So the FBD of the boom is, this is the boom. In this point, here is a force of 1500 Newton, and this is the tension of the string. Okay, and here is a pulley connected by a pulley. It is a pulley. So it is a pulley and connected by the pulley, and in the pulley, in the 11, we not need to consider the forces in the pulley, but in the college we need to consider the forces of the pulleys, and the forces of the pulleys, you just divide in 90-degree direction two forces. In the horizontally it is HA or XA, and in the vertically it is YA or VA. Okay, so it is done, and we need to find at first this angle, and also given in the question that it is in equilibrium. Okay, so you simply you can simply divide the forces in summation of fx equals to 0 and summation of fy equals to 0. So you can see that T is equals to XA and summation of fy YA equals to 1500. So we can find the YA is equals to 1500 directly, but T is equals to XA. We cannot find from that. We cannot find T or XA anything. So I point that this 2 point is AB as AB, and there is another condition of equilibrium, that is momentum summation of M is 0. Okay, so we need to also consider the momentum formula in this question. Okay, so here is the new page, and I am drawn the boom once again. Here is 1500 and here is T. It is XA and it is YA. From f of y is equals to 0, we can see that YA is equals to 1500. So YA is equals to 1500 Newton, and from fx equals to 0, we can see that XA is equals to minus T. XA minus t is equals to 0 means x equals to t. Okay, so x is equals to t, we can find it. And now we need to apply this formula. M, this is A, this is B. I considered that I take the momentum from the A point. Okay, now we can find this, we can apply this formula. Okay, so we consider the momentum from the A point. You can also consider the momentum from the B point. Okay, so we consider that the A point. From the A point, if we consider from the A point, the forces from the A point is ignored. Okay, this is the point. You think that this is the point, you think that this is a screw in the wall. Okay, and this is a stick. This is the screw in the wall, and this is a stick. It is point by the screw in the wall. Okay, and we apply the 1500 or 1500 Newton force in this direction. So the stick is circulate in this direction. In this means it is clockwise direction. Okay, if you apply, it is screwed, the stick is screwed in the wall, and if you apply the in this direction a force 1500 Newton, then the stick is circulate in this direction, means clockwise direction. And if you apply this force, T is in this direction. If you apply the T force, the stick trying to circulate in this direction, it is anti-clockwise direction. Okay, so these two forces are opposite. And what is the M? Means it is momentum. What is momentum? It is force to neglect the forces from this point. Calculate the forces from the other points is present. It is 1500 is a force into distance, means you can see that the force is in this direction, and the distance from the A point is this. So what is the distance between what is the distance? And we can also in the question here is also given that it is 30 meter. Okay, this is 30 meter, and this theta, we can easily find the theta. What is the theta? Sine theta is equals to perpendicular by hypotenuse. Means what is the perpendicular? This is the perpendicular. What is the length of the perpendicular? 15. What is the length of the hypotenuse? Is 30. What is then theta? Theta is equals to 30 degree. We can easily find the theta. So if it is 30 degree, then what is the distance between the force? What is the perpendicular distance? Okay, this is a perpendicular distance from the force. Okay, so it is 30, it is theta, so it is 30 cos theta, and it is 30 sin theta. So 1500 into 30 sin theta, it is 30 sin theta, means it is also 15 in the given question, that it is 15. So it is directly we can say that it is 15, and t is the opposite direction, so it is minus t into what is the perpendicular distance from the A point. T is in this direction, perpendicular distance is this. You can see that perpendicular distance is this. So what is the distance? It is 30. So it is 30 cos theta. 30 cos theta. And no other forces in the question. is given. So we can easily find that. You check my answer. It is T equals to 866 Newton. It is the final answer of T. So we find the T. So T equals to XA. We also find the XA. We also find the YA. So here is nothing more forces. So this question is done. Then we move to the next question. Okay, so here is the second question. In this question, it is little bit complex, but you can easily solve that if you follow my lectures accordingly perfectly. You can solve this easily. You just need to solve this step by step to draw the free body diagrams, and you can easily handle this type of questions. Okay, it is here is the two ball. This is touched by the two grounds. Okay, this is inclined plane and this is a surface, and the ball is touched with the two surfaces, and this ball is touched by this ball and this inclined plane. Okay, and it is given that it is 30 degree, and it is, and the two forces of the ball from the ball is 100 Newton and 100 Newton. Okay, find the reaction force induced by the ABCD. A means this surface, B means the two ball touches B, it is C, and it is D. Find the reaction forces by the ball surface. Okay, so draw the free body diagram first, one by one. We pointed out that it is one, sorry, it is 1 and it is 2. Okay, so first draw the free body diagram of the first ball. Okay, so draw it. It is the first ball. Okay, from this point it is forces acts on the ground is 100 Newton. Okay, and what the forces of the other forces in this ball, you can see that from the C point here is a reaction force on the first ball. What is the reaction force? It is RC. We considered that it is RC. So in this direction it is RC. Okay, from the point. And what the other forces? Here you can see that here is a reaction ball, it is RB, and you always remember that the reaction force from what surface, the reaction force is always the perpendicular to that surface which is reacting to the ball or something, some object, and from this surface the reaction force, it is also perpendicular to this surface, means it is in what direction? It is in that direction. Okay, what is that? It is RB, reaction force on the B, and here is the another reaction force on the D point, and the reaction force also perpendicular to the D point, so it is in this direction. Okay, so draw the reaction force from the D. It is like that, and it is the center, it is RD. In the question it is given that it is the 30 degree, so the angle between the RC, the angle between the RC and the 100 Newton force, it is also 30 degree. Okay, you can remember that it is also 30 degree. Okay, and we need to find this angle also, because we need to divide the RB in the two directions, x and b, x and y. So we can see that this is also 30 degree. See that from here, in this direction it is given. Okay, so it is 30 degree. It is given that in this direction, means it is parallel to the inclined plane, and it is ground surface, so 30 degree. You can see that it is that in this direction reaction force, and ground surface it is like this and this, so it is 30 degree. So now the FBD is done. We just need to now we just need to write the Fx and Fy forces. Fx, summation of Fx equals to 0, means what is in the Fx, it is Rd. Okay, now write Rd in this direction, and it is Rb. So we cannot divide like this and this. We always need to divide a vector from its tail position. So we need to divide in this and in this direction. Okay, so if we draw this RB in this surface of the ball, then it is RB. Draw it. It is RB, and we need to divide in this direction and in this direction. Okay, so you can see that it is the parallel line RB, and it is the ground line. So it is 30, means the angle it is 30. You read this you did this formula in the class 10, I think so. Okay, so there is no doubt, no need to create any doubt. Okay, so in the x direction, we can see that it is opposite to the RD, so it is minus RB cos 30. You can see that it is cos and it is sine. Okay, so what are the forces in the x direction? It is RC, so we draw it in this. It is RC. We can we need to draw from the tail position, means in this direction and in this direction. Okay, so you can see that this is RC. I am straight line to the RC. It is RC, and it is the vertical line, and it is the vertical line. So this angle and this angle is same, so it is 30 degree. Okay, please consider my drawing. Okay, it is not good. So it is 30, means it is the cos and it is sine. So x is sine, the x direction is sine, and it is RC. So what is it? RC sine 30, and what is the direction? It is the same to the RB, so it is also minus RC sine 30 degree equals to 0. From this you can get a equation that is like the RD minus 0.9 into RB minus 0.5 into RC is equals to 0, and you pointed this equation, that equation number, as equation number 1. Okay, so and what is the other equation we need? It is the Fy is equals to 0. What is the Fy is equals to 0? We divide the all components in the xy. So we just see the components in the y direction. Here it is a 100 Newton in the y direction. So at first directly see 100. Here also RB we divided RB in the xy, so it is in y direction, and it is the cos component, so it is the sine component. RB sine, it is 30 degree, so sine RB sine 30 degree. It is in the 100 Newton direction, so it is plus RB sine 30 degree, and the other is in this direction RC, it is the cos component, so because it is 30 degree, so RC cos 30 degree, and it is the opposite to the 100 Newton and RB sine 30 degree, so it is minus. So it is minus RC, it is RC's cos, means cos 30 degree equals to 0. And what is the equation? It is RB into 0.5 RC into 0.9 minus 100 Newton. You marked as it equation 2. You see that you cannot find you cannot find any reaction force from these two equations. You need to find any other equations. Now you can see that in the question here is 2 balls. So now we draw the FBD of the ball 2. Okay, so here is ball 2. It is ball 2. Okay, it has also a 100 Newton force in this direction, 100 Newton. And what the other reaction forces the ball 2 has? Ball 2 has the RA reaction. From the A we can see that RA is in this direction. RA is force to the ball in this direction, it is the normal force, and RA is perpendicular to the surface, so it is like this. Okay, so draw the RA is like this. It is RA connected to the center. Okay, and I previously told that from the from the RC it is 30 degree. So from the RA it is also 30 degree, because it is given as 30 degree. Here is a concept, I literally told you that, but you can remember this one. If it is 30, then the perpendicular to the inclined plane and the vertical line is 30 degree. Okay, so it is 30 degree. So draw it. It is 30 degree. And what the other forces is given in the 2? It is the B surface, B point. Okay, So surface is this, so reaction forces react in this direction perpendicular to the surface, so it is in this direction. Okay, so draw the B. What is B? In this direction, R B. And you can see that it is the inclined plane. You can see that it is the parallel to the inclined plane and it is the ground line, so the angle between that is 30 degree. Okay, the angle between that is 30, so it is also 30. You know that formula, I guess you should know this formula. Okay, now no other forces in the RB part, no other forces. It is 1, it is 2 and it is 3. Okay, so now we need to divide the forces in xy direction. So here it is 30. We cannot divide it like this from the head position. We need to divide it is from the tail position. Okay, so divide it from the tail position. We can see it is 30 degree, so it is Z, so it is 30 degree. Okay, so it is the cos component in Y and it is the sin component. We divide the RA. And what is RB? From tail position, head position. From tail position we divide the two components. It is 30, so it is X is cos component and Y is sin component. Now apply the summation of fx equals to 0. What is summation of fx equals to 0? We can see that in the X, here it is RA sin 30 degree in this direction, so it is RA sin 30. I am assume that this is plus, okay. And in the X direction, here is another force RB cos 30 degree and it is the opposite to the RA, so it is minus RB cos 30 degree. Now you find that RB is equals to 0.6 into RA. It is the another equation. And now what is it? Fy is equals to 0. What is Fy? Here you can see that Fy is present 100 Newton, so directly we assume that 100 in this direction it is plus, okay, 100. And here another Y, that is RA cos 30 degree in the opposite of the 100, so it is minus RA cos 30 degree. And here another Y, it is RB sin 30. It is cos component because it is 30 degree, it is cos component, it is sin component, RB sin 30, and it is the same with the RA. Okay, so it is also minus because it is opposite to the 100 na. 100 we assume that 100 is plus, so it is minus. Okay, RB sin 30 degree is equals to 0. Okay, so what is the equation? It is 100 minus RA cos 60 is 0.9 minus RB sin 30 is 0.5 into 0.5, okay, equals to 0. And you already get that equation, that is RB equals to 0.6 RA. So you put that RB or RA, you put that I am putting that RB is equals to 0.6 RA. Okay, so you can find the RA from this equation, and if you find the RA, then you can find also the RB. Okay, so we get that we get the RA and we get the RB. Okay, now here is the another two, that is RC and RD. You put the RA, you put the RB, you get that RB in the previous two equations. You put that RB, and in this equation you also put that RB. If you in this equation if you put the RB, you can get the RC. So in this equation you get the RC, and if you get the RC and RB you already gotten, and RC you get it from this. Okay, so RD you can also find. Okay, so here is the question. It is you can see that it is pretty complex to first time seen, but it is not a complex. If you follow my steps, if you follow the drawing, follow the FBD part of the two balls step by step, it is not a complex one. It will be very easy. I think every questions will be very easy from that. Okay, so this is for today. I will posted the uh, many harder problems in the future lectures from the mechanics part, and I will also go to the friction part. Friction is not reached yet. So if you have any doubt, you can ask me in the comment section, and I will also give my Instagram handle in the description box. You can ask me in the Instagram also. Okay, so have a nice day.